All right, well, thanks again, everyone, for coming and for sticking around. It's been a great 2 days, and it's been really exciting for me to see how many amazing osquery practitioners there are out there. So I wanted to just go quickly into some of the YARA scanning, and particularly efficient YARA scanning with osquery. So we mentioned a little bit about YARA yesterday, but we're going to go into it in a little bit more detail. So this is me here in the Outback. I'm living in Denver at the moment, and I've got a background in the security industry. I started in 2001 in Las Vegas with a digital identity resolution where we're matching identities of people getting on the planes to watch lists post 9/11, and then worked for IBM for 14 years doing data encryption and database monitoring. And then I said, crikey, look at this osquery tool, and moved over to that a year ago, and I've just been really excited with what osquery has to offer. So we're going to dig in here without further ado. So a quick overview of some of the IOCs, or indicators of compromise, that are being used nowadays. Some of them are related to networks, so URLs, domain names, IP addresses, and now JAR3 signatures. I'm going to be doing a webinar on JAR3 and osquery next month. But today what we're going to focus on is files. File hashes, MD5, SHA-1, SHA-256 has been the de facto way of identifying files in the past. And if you go on to the Open Thread Exchange, you'll see a whole bunch of those file hashes. But you're starting to see some YARA rules now published as indicators of compromise. And they're fantastic because, as most of you know, the issue with the file hash is that it's so easy to change, right? You can put a change at the end of a malware file, and any slight change will invalidate the hash. So all IOCs that were created, it's so easy to modify those. And here's an example of a remote access Trojan that blue teams and red teams can use, and it comes with an option here to basically randomize the hash. Here to randomize the hash. So it's very easy to change a hash. So YARA is a great solution to be able to come up with a signature for files that's much more resilient to change. So YARA is used to create those signatures for files, but also used to do investigation. We're going to dive into a few of the tools that are available for YARA for doing some research and talk about some use cases in the wild for pulling files, malware files and things, creating rules from them, and then using those scans across the rest of your enterprise to detect if you have any other instances of malware on your system. So what is a YARA rule? Here's an example of a YARA rule. It's got basically a series of strings. So these strings can be regular text strings in ASCII, or they can be hexadecimal strings, or they can be regular expressions, as was mentioned yesterday. So you can have a bunch of different strings and then a condition that defines, you need one or two of those strings, several of those strings, or a string and a regular expression, and so on and so forth. And you can really get very complex in the definition of the conditions that you use. So here's some examples where you say, you've got a couple of strings up here, and then you say, I'm going to have 6 of the A string, and the number of the B string is greater than 10. You can also define things like entry points, which are really nice for PE files, portable executables. So you can say that at the entry point to my file, I have this hexadecimal string. And you can do other things like look at the encoding, define the numbers of instances of strings, and all of these different conditions you can use in your YARA rules. So it's really super powerful. And let's look at a couple of examples of rules. So here's a rule for the Albertino Advanced Remote Access Trojan, and they're defining in here, looks like 7 different strings, and the condition is that all of those strings are present. in the file. Here's a YARA rule for a web shell detection. Talked a little bit about web shells yesterday, and this particular rule is looking for the step Russian malicious cyber activity PHP file, and it has some strings here defined. It's looking for the base 64 decoding here. It's looking for some other things, string replace, MD5, looking for is set and cookie, and then the actual condition in this particular case is that is set is found 3 times and cookie is found twice, and this file size is between 20 and 22 kilobytes. So you can really get really granular in these rules, and there's a lot of fabulous rules out there for detecting different remote access Trojans, web shells, and so on. Here's one for encoded PowerShell. So if you have a malicious PowerShell executing, it's base 64 encoded. This particular rule is looking for this substring here and then one of the following 2 patterns. So you can run YARA on Windows or on Linux or on Mac. Here we see that we're starting to see some of the YARA rules published as indicators of compromise. So this is on the Open Threat Exchange. This particular rule here, we have some typical file hashes and some IP addresses and so on, but we also have a YARA rule. So we're starting to see these used more and more, and they're being used in different ways. So in this particular posting up the top here, or pulse, we see that a YARA rule was found, and then they scanned their system and found 27 different files. And they actually published the SHA-256 file hashes in this case. So that's another way of using YARA. In fact, there's some folks here in the room that have been given a file hash in the wild and found a malware file. Then they used YARA to pull that data, analyze it, and then create a YARA rule, and then do a scan on the rest of their system to see with that YARA rule. And they found other files that were other instances of the malware that had a different hash, but because they were able to use YARA to create a neat definition of that malware, they're able to find it on other machines in their environment. There's some neat plugins that have been added to YARA, and here's one from Airbnb. This one's for serverless AWS pipeline scanning. So anytime you upload a file to an S3 bucket, you can use it to immediately scan that with YARA, based on a set of YARA rules in a file. Another one on payload extraction. So if you're examining a malware file and you want it to pull out specific sections on that file so you can create a YARA rule to identify it, then this can help you. And again, there's a file scanning framework that allows you to scan and pull out sections of the malware, and other utilities that will allow you to pull out IOCs like URLs and things like that from malware so that you can add those to your IOC library. Here's a bunch of other resources. There's a bunch of good resources out there for repositories of rules and tools, and you can check those out if you're interested. This is a list of advanced persistent threat YARA rules that are out there. So let's get started with YARA. Basically, we're going to install it here, and this is just a command line version of YARA. Here's an example of installing it on Linux. And this is for running the command line YARA. It's outside of osquery. We're going to get into running for osquery in a minute, but you can just install it and run it this way as well. There's some nice debugging information. If you're creating your own rules and you're worried about performance, then you can run the command line YARA, and it'll actually show you some hints and tips if some of your regular expressions are not that efficient, or if you've got like a string that's very short and it's matching up in very large number of instances, then you'll be able to see that. And here's how you run YARA. So you just run YARA and you say, here's the rules file that I'm going to use and the file or directory that I'm going to scan, and you can put a -r to recursively scan all the files in there. And the output is any files that match and the name of the rule that it matches. So in this particular case, we matched the evil OSX, remote access Trojan, this Python payload here in our scan. So it's very easy to get going, and you can run it like this from the command line, or you can, it comes with Python libraries so that you can integrate it with your Python if you want. Now, I went ahead and ran some scans to see how long scans took, and based on the number of files, we measured about 0.5 seconds for the Etsy directory. It's like 2,300 files. And then as the number of files increased, up to the user directory here with 600,000, it took about 123 seconds. So it's a pretty linear increase with the number of files. The scan time is going to increase. It's pretty straightforward, but you can imagine on a massive file server, if you were scanning 10 million or 100 million files, that could be a very long scan time. So it could become expensive. And the other factor that affects the number of resources that are used or the scan time, of course, are the rules. How complex are the rules, and how many rules do you have in your rule set? So here's a little analysis on scanning of the lib directory, where we increased the rules from 1 to 122, and we saw that the somewhat linear increase. It's not quite linear because, of course, as we increased the number of rules, we had some, in our case, we had some rules that were more complex than others. So we kind of jumped up here a little steeper because we had some more complex rules there, and then it kind of evened out because we had some fairly simple rules at the end. But something to be aware of, you're typically not scanning with orders of tens of thousands of YARA rules. In most cases, you're doing more of a targeted scan. So when you go ahead and run your YARA scan, you may see some feedback like this, and this is the warnings that I talked about around performance. So they'll tell you if a particular string is maybe not reasonable, maybe it's too short and you're getting a very large number of hits, and so you get this warning message. You'll get a warning message if it's slowing down scanning, and then if it's really slowing down scanning, you'll get a critical on that. So you can go through and have a look at those lines in your rules file and say, okay, maybe I'll go and adjust my rules a little bit to help improve the performance of those scans. So what happened when we ran our scan? We had a 2 CPU test machine, and it was running at about 193%. So it was using pretty much all of the resources during our YARA scan. So it was pretty intensive. And so we have to look at perhaps a way of really being more targeted in our YARA scanning. So instead of doing full scans, what kind of alternatives can we look at? Well, osquery gives us the answer because it allows us to do two critical things. One is to capture all the processes that are running. So someone yesterday said, hey, use the processes table, right? But even better than that is the process events table, right? Because the osquery eventing framework is not lossy, it doesn't lose any records. So that's what we're going to see here in a little bit. We're going to target the YARA scan to just use processes that have executed on our system via the process events. That's one way. The other way, of course, is there may be certain files on your system that are of high risk or that you want to scan that aren't running. So things like maybe users' downloads, maybe you've got a web server and you're worried about web shells, you've got some web code and you want to have that scanned. There would be a couple of examples, but you can enable that through file monitoring, FIM. So you say, I know the directories that I want to monitor, I'm going to turn on FIM, and then I'm going to turn on YARA for that FIM, and you'll start to see that come through in the YARA events. So for the FIM, for the file integrity monitoring, you basically, we're going to turn on FIM, and then we're going to turn on a YARA config, which is just a set of rules, and you can have multiple sets of rules, and then you can map the rules to the different directories or FIM sets of files, and then you'll start getting things in the YARA events table. And you'll no longer get stuff in the file events table, just FYI. But we'll talk about that in a second. So I think perhaps the identifier is limited to one table. So once you switch from, by turning on the YARA events, you'll no longer see records in file events. And then for the process events, we'll turn on the eventing framework and we'll use process events, and then we'll start running our YARA scans for everything in the process events table. So let's get cracking. We're going to download and install osquery with this command. You don't need the separate YARA. If you just have osquery, you want to do osquery YARA scans, you don't need to install the YARA command line that I did earlier. That's a nice to have if you want to do some debugging and so on, but you just need regular osquery. So what do you need to configure? In the osquery.conf, you're going to need YARA signature groups. So here you can do one or more signature groups, and they are each one or more SIG files, which if you're used to YARA, that's just a .yara file, just a list of rules. So they call them .sig files in osquery. They're just a group of signatures or YARA rules. Once you've defined your signatures, you then define the FIM paths, the file paths. So in our case, we're monitoring the home's private directory, we're monitoring some SSH keys, and the etc directory. But these groups, it can be whatever you want, and then finally you have to map those groups to the YARA SIG groups. And that's what we do here, where we say, oh, the homes directory, we're going to have the SIG group 1, which is going to be this set of YARA rules. And for the etc directory, we're going to have this SIG group, which is the same one, but it could be a different one. So it's a very simple setup inside of your osquery conf. So what happens once you start running this? Well, FIM is going to turn on based on those configuration, and it's going to start to look for changes to those files. When the changes happen, it's going to record a file event. Nothing's going to get written to the file events table anymore. And so what I did was I added a true YARA rule here. So I just called it file event and I said condition true. And what this allowed me to do was maintain all of those file events or file changes and just record them with the match that I called file event. Now, for other matches like this evil OSX remote access Trojan here that hit on this file, I'm going to get that recorded and it's going to show you the YARA rule. But if you want to see all of the file event changes as well, then you can put in this true rule because you're not going to get anything in the file events table anymore with this turned on. But that'll allow you to at least still know if any files changed. So this is a very nice way of saying I have my critical files, certain directories, downloads and so on that I really want to monitor. When you turn this on, then you'll monitor any changes to files and run the YARA scan that's associated with them. Now, let's talk about how we're going to scan things that we're not monitoring. So we're not going to use FIM in this case. We want to say, let's monitor everything that runs on the system, any process that executes the underlying file associated with it, which does have some limitations. You know, obviously Carl pointed out there are a lot of attacks that are actually in memory only and they don't have a file. But if they do have a file and they run, how can we configure osquery so that every process event gets a YARA scan on the file? So we just turn on the eventing framework. So in the flags file here, we're saying disable events false, disable audit false, and we're going to start capturing event data. And again, we've seen this. All you need for this here is to specify a SIG group. If you wanted to have multiple SIG groups, you can actually do a where SIG file equals, in which case you don't even need this. And then how does it look? Well, here we can see that we're just demonstrating here in osquery I. So, as soon as you turn on the eventing framework and you wait for a number of seconds as some processes running, you'll start to get process event records. And then as new processes spawn, you'll get those stored in the process events table. So there it is there. We're just saying, oh, how many process events do we have? And we've got 4. And now we're going to run a query. And we're going to select from YARA, which is an ad hoc YARA scan of, and you specify a path. and a SIG group or a SIG file. And so in our case, for our path, we're just doing a subselect to say, well, my path is going to be the distinct paths in the process events. And there you have it. So here are all the different processes that are running, those 4, and here are the matches to any YARA rules. And we can see that this Etsy syscheck matched with this anglerworm rule, and so we have our YARA result. So this is great if you want to do a test in osquery, but it's not really very scalable because you have to run osquery manually. I mean, you can kick off osquery from a tool, right? You can specify the osquery in the SQL, and you could execute it, but still, it's not the most scalable approach. So how can we integrate it with something like osqueryd if we're running the daemon? So here's a little example where we set up osqueryd and we're running some queries on a regular schedule, including a query that's selecting the path from the process events table. And so it's just dumping the osquery data out to a file in this case, and then we just got a Python routine that's reading the results of osqueryd here from the file, and then it's getting the distinct paths and building this query that we saw earlier. Select star from YARA, where the SIG file is X, and then the path is in the paths that we're seeing here in our JSON output from osqueryd. So this is just a simple little routine. If you're running osqueryd and you've got the output in a file, you can use this to regularly do YARA scans based on all of the unique paths that you see in your process events table. And if anyone's interested in getting a copy of it, you can come and see me. We can put it up on GitHub or something. But what happens if you're really running at scale? You've got thousands of assets. If you're running something like an elk stack, well, very simple process. You could basically run a query to get all of the distinct process events and then construct the queries like we talked about. Select star from YARA where the path is in those distinct values, and then use something like Javier's osctrl and execute those real-time queries from a centralized environment. Very scalable approach. And if you're using something like Uptycs, it's a similar setup where you basically just you're running a query here against our global store, which is similar to the elk stack, to get all of the unique paths that you're seeing in the process events, and then split out those unique paths and then query the individual assets. The same kind of thing. So this kind of thing would work across hundreds of thousands of assets. The caveat being that obviously because you're hard coding this here, you're running it fairly regularly, and so you're not expecting thousands and thousands of unique paths in these things. Obviously, once you get to that point, you might start having a very big SQL statement. So the regularness with which you're running these is usually pretty frequent, and you'd have to see if you ever got into a situation where some server had a characteristic where it was running a very large number of distinct paths and caused an issue, but shouldn't be a problem for most reasonable situations. So how much resources does it use? Well, we saw that the osquery agent is running about 5% CPU on our 2 core machines, so that's very different to the 190-odd% that we saw, which is nice. So it's a much lower resource utilization. But what happens if you have a very large number of files that you're scanning from YARA? Like I did a test on osquery and said, let's touch everything in the lib directory. There's thousands of files, and let's see how quickly the data will come through. And what happens is the data gets written to the YARA events table over time. So you can query it and you can see there's like 1,000, 2,000, 3,000, 4,000 records. So because it is limited on CPU, it actually is taking longer time to run the YARA scan than if you're just running YARA from the command line, because it's using less resources. So just be aware of that. If you really needed to scan a very large number of files with YARA, you might want to do that from the command line. But if you're using this targeted approach through osquery, it's a very good way to do it. So in conclusion, it's very powerful. YARA is a very powerful tool. for scanning, but you can get expensive, particularly if you have a large number of files and a large number of rules. But using osquery for specific files, saying I want to do file integrity monitoring on this specific set of files is a very efficient way of limiting the load, one. And then two, using the process events is another way of saying, hey, only these files that are executing on my system, I'm going to scan those as well. And then, of course, these, the method that we talked about for building a system of capturing the unique paths from process events and then kicking off these real-time queries, it wouldn't have to have that complexity if, in the future they had some method or enhancement to osquery where we could maybe have YARA event processing triggered from process events as well, and not just file events. It's just a thought there. If YARA becomes very popular and if people find that there's value from doing an analysis of the process event pass and pushing that through to YARA, then maybe that's a feature that might get requested in the future.